Simultus Functional Training, Part 6. Preparation of the CAD models and conversion of solids to STL format. In this part of the training, we will show how to prepare 3D CAD models that can be used in Simultus. We will use a multi-axis linear rotary module as an example. This can be done in two ways. We can download ready-made CAD models from respective websites or draw a model in any CAD program. After making the models, we will demonstrate how to convert them to a STL format. This particular format of 3D solid files can be imported into Simultus. We will start with an example showing how to download a ready 3D model of the device and how to use the Highwin wizard. Before that, we will show you some useful websites from which you can download ready-made CAD models. There is a button in Simultus's top menu which directs you to the program's help page. It contains addresses to websites from which you can download compatible 3D models. The first of them is the link to the Linmod website, offering linear and linear rotary servo motors. Here we have access to a catalog of linear motors and accessories for them. We will download a linear rotary motor model for our project. We will choose a compact motor with a stroke of 150 mm. At the bottom of the page, we have the option of downloading the model file. We will save it on our hard drive. To maintain order, we will save it in the same directory in which we will place our project. The models will be downloaded in step format, and later they will be converted to a STL format. Therefore, we will create two directories with such names. The next link on the website is a shortcut to a page with models of Estun servo motors, and a page where you can choose a planetary gearbox for them. After choosing the model of the motor and the gear size, we can download its 3D models and choose the file format that is convenient for us. In this example, we will not use these elements. We will proceed to a very interesting tool, which is the Highwin Linear Modules wizard. Models of other elements are also available on the page, but in our example, we will use the multi-axis Linear Modules wizard. Let's choose a 2-axis module and then the size of the module body. In the next step, we can enter the length of the module that we want to build. Let's assume that our module will have a stroke of 500 mm in the x-axis and a stroke of 1 meter in the y-axis. After providing this data, we can download the ready CAD model. But before that, let's check how it looks in the orthogonal projection or in the 3D view. We still need to choose a file format. The choice of format at this stage depends on our CAD program, in which the model will be prepared. As you can see, there is quite a lot of available formats. We select the file in step format once again, download and save it onto the hard drive. We have already downloaded models of all elements for our project. Let's return to the page with CAD models. There is also a link to an interesting 3D elements database called 3dcontentcentral.com. This site requires registration, but the access itself is free. There are many element models here, uploaded by official manufacturers as well. Here we can find models of the simplest components, such as grippers, but also more complex models, such as industrial robots. Wizards are available for many components, so it is easy to customize models to suit your needs. Here we can also choose the file format of your preference. Creating your own models in CAD programs is a time-consuming process, so it is worth using those wizards, especially at the initial stage of the project, when we want to quickly test our concept. Let's move on to the next part of creating our device model in Simultus. After downloading the 3D models, we must draw our device in any CAD program. In our example, we will use the free CAD software. It's freeware and there are many tutorials available on the internet for learning how to use this program. Let's import the previously downloaded models of the linear rotary motor and the 2-axis module to the newly created project. Please note that the axis names are different in the program than in the wizard. We will need to remember this when defining the axis in Simultus. In the tree on the left side of the screen, we can check which components are featured in the downloaded devices. The Linmot linear rotary motor consists of two elements, a stator and a slider. The 2-axis module consists of a block moving in the x-axis, a linear model of the x-axis, and 3 elements of the linear model of the y-axis. At this point, we should pay attention to a very important issue. The elements of our models, which we will move independently, have to be separate solids. This is because we will have to export them as a separate STL solids for Simultus. As you can see, this condition is met in this example. The next step we need to take is to set the components in the right position. We can also do it in Simultus, but it is easier to do it in the CAD program. We suggest aligning all of the model's elements in their desired places at this point. Let's move the linear rotary motor so that it's attached to the block of the 2-axis module. At this point, we could draw more elements to our device, but we do not need them in this part of the training. All elements are already in place, so we can proceed with exporting solids to our program. As we have mentioned earlier, independently moving solids must be exported to a separate STL files as separate 3D solids. Let's select the first element. It will be highlighted in green. Then, from the File menu in the FreeCAD, we select the Export option. We save the file with the desired name. Let's label the elements so that they are easier to recognize by their name than just by symbols. The linear motor stator and the block will move together, which is why we can export them as one solid. While holding the Control button, select both elements and set the name as Starter and Block. The next solid is the x-axis module with a length of 500 mm. Let's call it Module 500. The next 3 elements are a double module with connectors. They will be motionless relative to each other. Therefore, they can be also exported as one solid named Module 1000. All the elements of our device have already been saved to STL files. We can now import them into our project. Let's move to the Simultus program now. Let's open a new project and import the solids that make up our device in the 3D visualization window. The elements have appeared on the list at the bottom left of the screen. There is a slider, the stator with the block, the module with the stroke of 500 mm, and the base with the module of 1000 mm stroke. Let's change the color of individual elements. Let's adjust the size of the project area to our device. It was described how to do this in the previous episode of this course. Let's change the range of the area in the X, Y, and Z axis. In the Options menu, we can also set the light intensity. Please note that it took us only a few minutes to piece this device together. We can already show it to a client, or it can be used internally to discuss our concept. For now, however, it is not moving. In the next part of this training, we will show you how to easily create kinematic relationships for our device and to see how it works. We invite you to the next part of this training.